Welcome to Analog Microelectronic Circuits lecture, and this is lecture 11 on Unit 2. And today we will look at various numericals on amplifiers, including the biasing of the amplifier. So far, we discussed the theory part and the derivations of amplifiers. So today we'll start with the numericals. All right. So let us start with this question. The circuit is given. It is biased with a collector current of 1 milliamps and RC, which is a collector resistance of 1 kilo ohm. Question is to determine the small signal voltage gain, and small signal voltage gain input and output impedance if beta value is given as 100 and VA is given as 10 volts. So this is the question. Okay, the circuit is a common emitter amplifier. This is V in, this is V out, this is VCC, and this is given as 1 kilo ohm. Okay, so you can start solving this. Let me check with one of you. Tanush? Tanush, are you there? Yes, yeah. Tanush, can you help me? You can unmute, and can you help me in solving this question? So how to start? Okay, okay. All right, Renuka?
Yes, sir.
Yeah, so Renuka, can you tell me how to start with this?
Sir, I didn't follow the last class due to some lag in your audio and video, sir.
Yeah, but this is not based on the last class lecture. Yeah, this one is not based on last class, because last class we were discussing on common emitter amplifier with degeneration. That's all right. Okay, let me check with Subramanian. Are you there, Subramanian?
Yes, sir.
Yeah, Subramanian, is it okay for you to?
Yes, sir.
Yeah, please. Yeah.
So first we can draw the small signal model.
Okay. Yeah. Why small signal model? Because the question asked is based on small signal voltage gain and other things, right?
Yes, sir.
Yeah. Very good. Okay. Then.
And then we can solve. We can solve for small signal voltage gain by taking the finding V in. This is V
Yeah.
pi,
Mm-hmm.
and V out using the KVL, and which is minus GMV by RC.
Yeah. So if you remember, we have already we did this calculation, right? And now we have the final formula with us.
Yes, sir.
Yeah. So that we can directly use the formula. No need to do those calculations again. Say for
Okay.
example, if you know voltage gain, what is the formula for voltage gain?
Minus GMRC.
Yeah, minus Gm. Yeah, but it is given that VA. So what is VA voltage?
VA is 10 volts. So we
Yeah,
have to include
R naught
R
also.
naught. Yes, sir.
Yeah, so it is minus Gm into RC parallel R naught is the formula, right?
Yes, sir.
Yeah,
And
very
Rn
good.
is beta by GM.
Yeah, I'll check with others. Very good, Subramania. I think you got you're okay with this, right?
Yes, sir. I've caught up.
Yeah, okay, very good. Meher Amrit, are you there? Yeah. So Meher, can you tell me what is the next step? So we know the voltage gain formula. So how did we arrive at this formula? Because we did the analysis before. Yeah. So that is it. Now how to proceed and get the answers for this numericals, the numbers for the voltage gain input and output impedance. How to what is the first thing to be evaluated? Hello, Meher. Yeah. Yes, you want to respond? Yeah.
No, sir.
What happened? Okay, Meher. So, yeah. So contact me today itself. Okay, after the class,
Okay, sir.
sometime in the afternoon, you can call me. Yes.
Yes.
Now, Praveen, are you there? Hello, Praveen. Praveen.
Yes, sir.
Yeah, Praveen. Yeah, please help me in this. No? What to do next?
So for finding the input impedance and output impedance, we have to connect I test and V test, sir.
Yeah, we know that, and we already have the formulas with us, right? So no need to calculate that again.
Okay, sir.
Yeah. So can you tell me what is the input impedance formula for this? What is R in?
Sir, Rn is beta by Gm, sir.
Beta by Gm. Okay. Yeah, beta by Gm is nothing but R pi, right? I can write it as beta plus 1 into Re. What about R out?
R out is RC parallel R naught, sir.
Very good. Okay. Now we have all these expressions with us. Now we need to calculate and we need to get the numerical answers for this, right? So what is the first step to be done for that?
Sir, R naught is 1 by VA, sir.
R naught is 1 by Va.
Sir, no.
We need to write or we need to get the small signal parameters here, right? The small signal parameters are, I need to get the value of Gm, also the value of R naught. Beta anyway it is there, and even Re also, right? These things we need to evaluate. So how to evaluate Gm? I'll check with someone else. That's all right. So Anushka, so how to evaluate GM, Anushka? Yeah, what is GM? How to evaluate GM? Okay. Rakshit?
Yes, sir.
Yeah, Rakshit, can you tell me how to evaluate GM? Could you listen those lectures?
No, sir, I still haven't completed.
Oh,
I have
okay,
to
okay.
start BJT, sir.
All right, all right. Naveen? Naveen?
Yes, sir.
Yeah, Naveen. Can you tell me how to evaluate GM?
GM I don't know, sir. R naught is 10 by RC.
RC?
Yes,
R0 is a resistance, right?
yes, sir.
So if I write this as 10 by RC,
10 by RC, IC dash, IC,
IC,
IC dash.
IC dash. What is that IC dash? IC dash is the collector current, right? It is IC itself actually. What we have written is the collector current itself. So I can find R0 here as 10 by 1 milliamps. So that is equal to 10K, right? Now Nishant,
Yes, sir.
yeah, Nishant, what is GM?
So GM is IC by VT,
Very good. So
1
IC by
milliamp,
VC,
1 milliamp by 26 millivolts,
millivolts.
uh, 0.0385.
Very good. So 0.038. What is the unit of this?
Siemens per
Yeah,
ohm
amps per
inverse.
volt. Yeah, very good. Yeah. Now what about RE?
R pi by beta plus 1.
Okay, so what is R pi?
Okay. So R pi is thermal voltage by IB. So IB I can write IC by beta.
Okay, okay. So that way you can write, or you can write. So you can
So
approximately take.
R pi is beta by GM.
Okay, okay. R pi is beta by GM. Oh, you have beta and GM. You can directly find. Very good. So no need to evaluate RE separately. So R pi I can directly write here. It is beta by GM, which is equal to beta is 100 in this case, and GM is 0.038. So that will directly give you R pi. What is R pi? It will be 2.6 kilo ohm, right? Yeah. So with all these three values, you can write the values for AV, RIN, and R out. So all of you, everyone can do the calculations, and you can post your answers in the chat box. Pallavi?
Yes, sir.
Yeah. So Pallavi, did you get the answer for voltage gain?
I got it as minus 34.909.
Very good. Minus 34.909. We the unit of gain is actually gain is a dimensionless quantity, but we will write it as V bar V. The meaning is volts per volts, right? What is voltage gain? This V out by V in. So in that way, we can write the unit as V bar V. That is again a dimensionless quantity. Yeah, that is right. Yeah, thank you. Parnika, are you there? Yeah, Bhavan. I saw the answer you posted. Yeah. Ashwit Kumar.
Yes, sir.
Yeah. So Ashwit, what is R in?
Rn is R pi, that is
R pi.
2.6 kilo.
Very good. What is R out?
0.909 kilo ohms.
0.909.
Kilo ohms.
Very good. Okay. So it is approximately 909 ohms. Yeah, right. So I hope this question was clear. If you have any doubts in this, you can post in the chat box. Otherwise, I'll give the next question. And the next question is yeah, the question is this. Common emitter stage is biased at a collector current (1 milliamps). The circuit provides a voltage gain of 20 with no emitter degeneration and 10 with degeneration. Determine the value of RC, RE and input and output impedances. Can take the value of beta as 100. So I request each one of you to do this problem. So I think if you can solve this, the meaning is you are clear with the amplifier concept, at least common emitter and common emitter with degeneration, right? And once the theory part is done, I'm not telling you should remember all the formulas every time, but it should be in your memory. In the see we have derived the formula and we have the formula with us, right? So when a circuit is given, through mental calculations, at least you should know the gain is gm into rc parallel r naught, or the gain is gm re by 1 plus gm re. So in that way, if you remember, because this is the second time we are getting the same kind of formula. The only difference is in MOSFET you have the resistances are named as RD RS. Here it is named as RC RE. Right? The formulas almost remain same. So it is better that if you remember the formula, remember in the sense remember with understanding, then it will be easy for you to solve numericals. Otherwise, you may have to think and write the formula, and sometimes there can be mistakes in that. So you should be ready to do the calculations on the side of a paper, like at least partially mentally, so that you can get the answers and solve with the questions. Okay, so while you guys can solve, I'll check with few of you. Naman?
Yes, sir.
Yeah. So Naman, can you tell me how to start with this numerical?
So I'm starting by drawing the small signal model because I don't remember the formula. So I'll first derive it and then I'll do it.
Okay, yeah, that is what I was about to tell now. So every time no need to derive it again and again, right? So if you understand if you know the procedure to evaluate or to do the small signal analysis, that is enough. Right. One, yeah, because doing the same steps again and again will not help, right? Yeah, for now you can do, because it's the first time we are doing such these kind of questions. But I would request all of you to be familiar with the formula so that you can solve it when you get a question immediately.
Okay, sir.
Yeah. Naveen? Naveen, are you there?
Yes, sir.
Yes, Naveen. So Naveen, can you help me how to start this?
The given voltage gain when no degeneration is done is
Okay.
20.
Okay. So what should I do for that? So no degeneration means what is given as 20?
Excuse me, sir.
Yeah,
So I have a small doubt. The AV over here is zero, right? The early voltage.
0.
Is
VA.
it? Oh, I mean, yeah, VA. Sorry, VA. The early
VA is
voltage.
not given, so you can neglect R naught.
Yeah.
Yeah. Yes, Naveen, go ahead.
The formula we have to written, sir.
Yeah, what is the formula? That is what I'm asking.
When degeneration is done, the voltage gain is minus GM RC divided by 1 plus GM RE.
Very good. So I'll take the magnitude because anyway it is given that voltage gain is 20. That means the given thing is magnitude. So I'll take this as GMRC by 1 plus GMRE, right? This is given as 20 or 10. If the circuits provide a voltage gain of 20 with no emitter degeneration, so 20, so this is 10 and this is 20. So what is 20 here? GMRC is 20. Right.
Yes, sir.
Yeah, so if we identify these two things, that's it. You can easily do the rest of the things. So GMRC is given as 20. So to get the value of RC, you should evaluate what is GM. So how will you write GM? GM is IC by VT. So IC is 1 milliamps and VT is 26 millivolt. So you will get GM value. So from that, you can arrive at the value of RC. Now, if GMRC is given as 20, then this ratio is given as 10. So the meaning is this implies that 1 plus GMRE is equal to 2 because 20 by 2 is 10, right? So 1 plus GMRE is 2 and this will give you the value of RE. Now, yeah, input and output impedance, you can write it for both the cases. Yeah, it is what is asked is for the degeneration case. So you can write R in and R out. Yeah, so you can solve and let me know the answers.
So excuse me, sir.
Yes.
Sir, how did you do that 1 plus GMRA is equal to 2, sir?
Okay, so see, in the question it is given that the voltage gain is 20 with no emitter degeneration and voltage gain is 10 with the degeneration. So I wrote this equation. GMRC is given as 20, GMRC by 1 plus GMR is given as 10.
Okay, sir.
Okay, so since GMRC is 20, 20 by 10 is 1 plus GMRE. Is it clear?
Yes, sir.
Okay. Okay, so I can see the answers here. Bhavana, yeah, Bhavana, I think you have given answer for the gain. Karthik, RC is 526.3. Can you check that again, Karthik? It is not
Sir,
520.
it's 0.52K. I
Yes,
expressed it in.
right, yeah. So RC is 520 ohms.
Yes, sir.
That is right. Now RE is 26.31. Akram is 26. Yeah, RE is actually 1 by 26.31. Yeah, now what is R in? Yeah, Bhavana, you also got the same answers. R, C, R, yes, Maheshwari also. Then, okay. Manikandan, it is 26 ohms RE, yes. RC is, yeah, that is right. Now, R in, yes. So, what is the value of R in? Rin is 2.63K. Okay. Can you check again R in and R out? So what is R in? Including RE, including degeneration, I can write R in as beta plus 1 into RE plus RE. Right. So that is R in. Now what is R out? Can you tell me what is R out here? R out. Namit?
Yes, sir.
Namit, what is R in? R in value?
Sir, just 2 minutes, sir.
Yeah. Kirtana, R out is not RE parallel RE. Okay, let me just draw the circuit diagram here. This is a circuit of with degeneration, right? This is RC and this is RE. This is V in. Now input impedance is here, which is equal to small re plus capital R into beta plus 1, that you need to evaluate. Now R out is actually the resistance seen down in parallel to resistance seen up for the circuit, right? So it is basically RC parallel to the resistance seen down, and we know that the resistance seen down, we have written the expression the other day. Yeah, something like this. R naught into 1 plus GM R pi parallel RE. Now we know that what is the value of R naught here? Since VA is not given, or we are not considering R naught, that means your R naught is infinity. Since your R naught is infinity, your output impedance is actually equal to RC. It is RC parallel to the resistance seen down. Since your R naught is not given, or R naught should be taken as infinity, in that case your R out is equal to RC. So I think your answers are this is close to 5.2K and this is RC itself, which is 520 ohms. If you are getting some different answers, you can just let me know. I'll check. Kirtana, is it clear? It is not RE parallel to RE. RE parallel to RE is it is actually at the common emitter, common collector mode. Okay, Kirtana, yes. So Maunav, you can check R in once. Abhirami. Maunav and Abhirami, you can check R in. Okay, if you have doubts, you can post here. I'll give you the next question. A circuit is given. Yeah, so this is a circuit diagram. The question is calculate. So far we have taken only the standard circuits. Now slight modifications will be there, but still you can find what amplifier is. So you are asked to calculate IB, IC, and RE. Also, the question is to determine Zin, which is input impedance, Z out output impedance, and voltage gain AV under two cases. One is you can consider R naught as infinity, and second case is you can consider R naught as 50K. Yes, Jessica. Rin is 5.26. Okay. Yes. So, what type of amplifier is this? Pradyumna? Hello, Pradyumna. Pradyumna is not there. Okay. Nitin Teja?
Yes, sir.
Yeah, Nitin, what amplifier is this?
Sir, this is common source.
Very good. This is common, not common source, this is common emitter.
Okay. Sir.
Right. This is a BJT based, right? So this is common emitter.
Oh, okay.
Yeah. So we know how to find R in, R out, and AV, but still let us do from the beginning. So let us start with IB. Can you tell me what is IB value?
Sir, 1 minute.
Yeah. Okay, Pradyumna. It is CE amplifier, not CS, CE amplifier. Yeah, so all of you can try this calculation. So how to find IB here is, we know that IB is the current at the base, right? This is IB current, this is IB, and current at this node is IC, and this will be IE. Now to find IB, so what I'll assume is the transistor to be in active mode to work as an amplifier, and so how will I say that it is in active mode? Because you can see that there is a capacitor here. Your input is connected to the circuit through this capacitor. Okay, before that we should see that emitter is kept common. So this is actually a common emitter amplifier. Common emitter amplifier. Now the DC voltage to the base is fixed through a resistance 390k, and that is 10. So base is connected to 10 and emitter is connected to 0. This is a PN junction, and possibilities are there that this can be forward biased. Now to the collector base junction, your collector is connected to a voltage of 10. Base is also connected to a voltage of 10 but through 390k. So with that I'll assume that collector base junction will be reverse bias. So for collector base junction to be reverse bias, the voltage difference can be as small as 0.4 or 0.3. Then also we can say that those junctions will be reverse biased. If that is the case, first I'll find what is IB. So how to find IB? IB is this current. Now if this PN junction is forward biased, and given that one more thing is given, this is a silicon transistor. Now if it is silicon, then this voltage in active mode, the base emitter voltage VBE is actually 0.7. So I'll take this VBE as 0.7. When I say VBE as 0.7, emitter, yes, Karthik, I think, oh yeah, many got answers. Yes, it is 23 microamps. Very good. Yes. So VBE is 0.7. Since the emitter is at 0, I can say VB is 0.7. That means this node I have 0.7 as the voltage. Now how to find IB? IB is not coming from here. IB is actually coming from here. So IB can be written as 10 minus 0.7 divided by 390k, which is equal to 23.8 microamps, which is IB. Now once IB is obtained, you can find IC, which is beta times IB. Yes, Manjunath, it is 2.3 milliamps, which is IC. If these two are there, you can find RE. What is RE? RE is actually VT divided by IE. What is IE? IE is the sum of IB and IC, which is closely 2.40 milliamps. I think if you write the exact value only, we will get this. It's 2.385 milliamps. Then IC is very close. Yeah, it is 2.407. Yeah, 407 or 408. So from this we'll get RE. RE is equal to 10.79 ohms. 10.79 ohms, which is RE, small RE. Right. Now, I hope this is clear. Now, if you know the value of RE, you can find the rest of the things, Z in, Z out and AV for two cases, which is R0 equal to infinity and R0 equal to 50. So, let me take case 1 here. So, case 1 is R0 is equal to infinity. If R0 is equal to infinity, I can write AV as minus GM into RC. Since it is a common emitter amplifier, AV is minus GM into RC. Yes, Kirtana, it is 10.7 ohms. RE is 10.7 ohms. Yes. Since if you know the value of RE, along with RE, you can find from RE you can find GM value, and that will give you GMRC, which is voltage gain. Right. So what is voltage gain? Any answers for this? What is voltage gain? $395.27. Yes, 395.27. $394. Okay, that is more accurate. 394. Okay, I think I am getting around 398. Yeah, 398.24. Yes, 398.33 something. Yes. So your voltage gain is equal to minus 398. That is okay. If you are getting 395 onwards, that should be fine. Because that depends on the decimal points what you take for your currents, right? Yeah, so this is voltage gain. Now for the same case, you can write input impedance Z in. What is Z in? Okay, so let me do one thing here. In order to find input and output impedance, let us draw the equivalent circuit. So what is equivalent circuit? Because now in this question we have an additional resistance 390k, right? So let us draw the equivalent circuit first. This is R pi. Emitter is connected to ground. Now from base, I'll use a different color. From base, I have a different resistance, which is 390k. That is connected to 10 volts, but that should be connected to ground because 10 volt that will be AC ground. Then now this is V node. At the output, since the R0 is 0, I can add only this resistance, which is 4.3k, which is V out. Right. Now your input impedance is the impedance seen from here. Output impedance is the impedance seen from here. So what is input impedance? So input impedance Z in here is equal to R pi parallel to 390k. What is R pi? Beta plus 1 into RE, which is parallel to 390k. So RE value we know. So substitute and get what is Z in. Z out is equal to directly 4.3k itself because there is no other resistance connected there. Right. Now, I hope you are getting the answers for this. Let me check. R pi parallel to 390. Yeah, that is right. That is right, Kirtana. Yeah, Namra, your answer is right. Karmugilan, Abhirami, Huma, Jayaditya, Kiran Kumar. Yes, that is right. Now, you can evaluate what is Zin and tell me the value for Zin. Similarly, you can do the second case. Second case is, second case is with R naught value. So I'll write here as case 2. That is with R naught value. I think I have given it as 50K. So if R naught is 50K, let me write what is voltage gain first, AV. AV is equal to minus GM into RC parallel R naught. You have to consider R naught also into picture. So that will give you this value. Now, yeah, now you have Zin. Zin remains same because there is no change happening on the input side. So whatever value you are getting here, the same value you will get there also. But Z out there is a change because Z out is previously it was 4.3K. Now let me add the new resistance here. I need to connect R naught, which is equal to 50K. So your Z out is equal to 4.3K parallel to 50K. 4.3K parallel to 50K. So can I get answers for this Zin? What is Zin? If you evaluate, your Zin is very close to, I think Zin will be close to R pi only, right? What is the value of R pi? With 101 into RE, 101. So it is around 1K. Yeah, 1.08. That is same here also, 1.08K. This is also 1.08K. Can tell me the new AV and new Z out. You can check the answer. AV will be minus 366.79. Yeah, Z in out. Karthik, I didn't get that. Z in out is what? Z out. Z out should be, yeah, right. It is 3.9K. Yeah. So these are the answers. So those who have doubts can ask now. I'll just stop this recording.